Solving a system of linear equations using elimination with addition. Solve the following system of equations. 3x minus 8y equals 7, and negative 3x plus 13y equals negative 17. Now, in order to do elimination, I need to make sure that I need to decide if I'm going to cancel my x variables or my y variables. Now, right away, I like my x variables because they already have the same coefficient 3. And in fact, they already have opposite signs. This one's a positive 3x and this one's a negative 3x. That means if I add these equations right from the get-go, they'll cancel out or eliminate. So I'm just going to add these equations like this. So 3x plus a negative 3x is 0x. Those cancel, exactly like I wanted. That's why it's called elimination. Now negative 8y plus 13y is going to be positive 5y. Now 7 plus a negative 17 is going to be negative 10. So my x's canceled out, and now all I have left is a y variable that I get to solve for. So in order to solve for y here, I'm going to divide both sides by 5. And y equals negative 2. But I'm not quite finished with this problem yet because I only have half of my answer. In order to have a solution to a system looks like this, with two pieces, an x piece and a y piece. Now I've solved for my y piece. All I have to do now is figure out what my x piece is. So I'm going to take this negative 2 and go back to one of my original equations and plug it in for y. I'm going to choose a first equation because it looks a little bit simpler. So I have 3x minus 8, but instead of y, I'm going to put negative 2 equals 7. And I just solve for x. So 3x, a negative 8 times a negative 2 is a positive 16. I'm going to subtract 16. So I get 3x equals negative 9. Divide by 3, and x equals negative 3. So I found my x piece. So the solution to this system is negative 3, negative 2.